In this video, we're going to look at some of the key highlights of a sampling distribution, and we're also going to show you how to do some computation on the probabilities using that same normal CDF command that we used earlier in this chapter. So whenever you kind of get to the test, or whenever you're doing your homeworks, one of the things that will kind of highlight this particular material from the stuff that we've done before is the fact that now we're going to have a sample size that's going to be involved. So you fix a sample of size n. You then go ahead and you compute, or you gather every possible sample of that size you can create from your original distribution, and then you can compute all of the different sample means. And the mean of the sample means, which we call mu sub x bar, it turns out that that's equal to the mean of the original distribution. Okay, so that's one very important thing we need to know. Again, with any distribution whatsoever, when it's normal, you need to know two values, the mean of it and the standard deviation. It just turns out that the mean of the sample distribution is the same as the mean of the original values altogether. The standard deviation, which is sometimes called the standard error of the mean, though, will be a little bit different. To find the standard deviation of this new distribution, you simply take the standard deviation of the original distribution and you divide it by the square root of your sample size. Okay. So again, very, very important. When you read these problems critically, whenever you hear the phrase sample size, or if they say little n equals, automatically your mind should go to the sampling distribution, and the very next thing you would want to do is write down and ask yourself the question, what is mu sub x bar? What is sigma sub x bar? Okay. For example, let's suppose we have a population with a mean of 100 and a standard deviation of 15. Find the mean and the standard deviation of the sampling distribution of the sample means if the sample size is 20. So for our mu sub x bar, again, that should be the same thing as mu in the first place. So mu sub x bar will also be equal to 100. The sigma sub x bar, that should be equal to sigma divided by the square root of n. Sigma was 15, n was 20, so 15 divided by the square root of 20 is going to be equal to 3.35. These are respectively the mean and the standard deviation for this brand new sampling distribution. Okay. The classic kind of problem that we'll have to do with this kind of material would be something along these lines. For example, suppose you have a sample of size 81. Find the probability of a sample mean being less than 32.5 if the mean was 32 and the standard deviation was 2.4. Okay. So reading it through, we see that they say the sample of size 81. So we already kind of should think that we're going to be working with a sampling distribution. Our mu sub x bar is the same thing as the original mean, which is 32. Our sigma value is going to be, sigma sub x bar is going to be sigma divided by the square root of n. That's 2.4 divided by the square root of 81, which is approximately about 2.667. And we want to find the probability of our sample mean being less than 32.5. Sample means are the objects that belong to the sampling distribution, so this is going to be a problem where we're computing it using mu sub x bar and sigma sub x bar. Again, as before, you want to try to draw a rough sketch of this. This is my sampling distribution. Its mean is the 32, so that's going to go right here. And we want the probability that our sample mean is less than 32.5. 32.5 is right here, and less than means we would have everything to the left that's going to be shaded. So we should be able to compute this using our normal CDF calculation. We go second, distribution, normal CDF. Because the shaded region goes all the way to the left, it should be negative 1 E99. The upper bound, or right bound of our region is the 32.5. And now we just need to enter the mean and standard deviation. Because this is a computation in the sampling distribution, our mean needs to be the mu sub x, which was 32. And our standard deviation needs to be the sigma sub x bar, which is the 0.2667. We go ahead and hit paste and hit enter, and we would find that the probability of that sample mean being less than 32.5 would be about 0.9696. As a follow-up question, they ask us, would that be an unusual event? And the answer is no, because in order for an event to be unusual, it would have to be less than 0.05, and this probability is much, much larger than that.